Mm, 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 mm. I kind of like the music. Da, 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 ba-da-dum. What's up, noise? Shifter says easy. Get better? Wow, you guys gotta chill. All right, I'm gonna stop the music. Actually, I do really like that music. Honestly, it's super fun. Where's this? Requests, all this. Cool. We got Sawyer up in here. Nice. Good to see you, OP Black. Yes. Oh, here. Let me change. Let me give Hypatia a cool nickname. One sec. Let me give you a nickname. I like your nickname. Hypatia. Actually, let's. I think there's like a cool spelling to it. Oh no, it's just Hypatia. I thought there was like an accent on the A. Okay, cool. I give you a cool. What's up, Sawyer? How's the AI bot stuff coming along? I was sending a funny picture to Noise here earlier. I thought it was pretty funny. I feel like there's always a general progression in like what's like the next new thing. It was like NFT, and then it's the metaverse. Now it's AI. There's always something. It's cool. Because I think Noise was saying, what was it? WWDC was today. That's the big Apple conference. Let me see. What is it? WWDC. Yes. Apple's releasing a VR headset. That's cool. A little late to the game, Apple, but you know that's how Apple works. They're late, and then they just come in with like, oh, and this is the de facto thing.
How's it going?
How's it going, Ramton? How's it going? Are you into VR at all, Ramton? Do you like VR?
Uh, I've tried the one game that I really like is like the boxing one.
Oh yeah.
It's like a workout or like there's like also like an actual boxing one.
Uh-huh.
Uh, that's the one I like the most. I know like a lot of people get
Super Hot. They love
dizzy.
Super Hot. Super Hot is good too. You've heard of that game?
No.
Here it's Super Hot. It's like you're fighting all these kind of like these ninjas red
Oh
things.
yeah, that would be.
Yeah,
I
this one
want to get
it's got
a
the guns
VR
and stuff.
headset, to be honest.
I gave one out last summer. I gave out a MetaQuest 2 as part of like one of the prizes of things. Yeah, this is a super fun game. People love playing this one. It's
Yeah, that seems good.
it's
Yeah.
cool. I don't know. It's kind of like a novelty. Like I had one, or I still have one, and after playing it for like a week, I put it down. I was like, oh, I don't really care about this thing anymore. So
Yeah, there's like a shooting game as well. Like, it's fun.
yeah, there's
Um,
Population
because
One
one
is.
of my friends has it, but yeah, I don't know if I wanna right now. I wanna drop any money on it,
I
but
know, good because they raised the
yeah,
price on it. When they first released the MetaQuest 2, or it was called the Oculus Quest, is what it's called. Then they renamed themselves. Um,
okay.
but
Yo,
it used to be super cheap, and then because they were selling it at a loss, and then they realized like, oh shit, we can't keep selling it at a loss, so they had to raise the price on it. Yeah. What's up, Shaq? Welcome back.
I'm
That's
on
dope.
medicine.
You're on what? You're on the medicine, dude. What's up? Are you sick?
Yeah.
Damn,
No,
dude.
no, no, no. It's like to numb my body type ish a little
What?
bit.
Why are you numbing your body, dog?
Because no, 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 no. It's not funny. It's
Uh,
something
oh
serious.
no,
Yo, I
dude.
feel so weird because I just recorded this video
Yeah.
and I am so like out of it right now. I feel high, but I know I'm not high,
What did
but
you
I could
take?
be high.
What did
I
they
don't
give you?
I don't know what it's called. It's literally like this doctor thing in the bottom. I can't read it. Some long ass shit. But
Yeah, it sounds
but
like
it's like
you probably got given
it's
like
like
muscle relaxers or something, dog.
yeah, I think it's like a muscle relaxer
Uh
because
huh.
on the 25th of June I'm going to have surgery.
Oh
So I
shit,
have to
dude.
like basically prepare myself physically and mentally.
Yeah, surgery is. I've only had surgery once, and yeah, it's not a light thing, dude. It's because they put you under, right? You're gonna go under.
Yeah.
Yeah, it's super
So
weird.
I think this is something to like ease it or something. I don't fucking know.
It's to probably get accustomed to like just being knocked out, because honestly, it is kind of a scary thing to lose consciousness, I guess is what it is. It's like dreaming while you're awake and whatnot.
Yeah,
But
I just hope I don't wake up because if I do, I'm gonna feel a lot of shit hitting my spine. So
yeah. Usually what happens, so my whole surgery experience, because I had to get, I like screwed up my pec muscle snowboarding once, and like they had to go reattach it and things. And usually what happens is they give you something like Valium or like a pill before, which will like chill you out and relax you. And then they bring you into the operating room, and then they have you like count down from 10 or something. And then like it's like lights out. And then it's like you're waking up from a dream, and then you wake up and you're like, oh, what happened? And then they're like, oh, we like sewed you up. So, um,
yeah, it's pretty scary. It's gonna be my first ever surgery.
yeah, dude. Well, you know,
Yeah, hopefully it'll go well. What's the surgery for? If
yeah.
you
What's
don't
it
mind me.
for? If you don't mind us asking you.
It's like this thing I had when I was younger.
Uh huh.
It's kind of hard to explain, especially right now.
It's
If
okay,
I
dog.
remember, I'll probably just text you.
Okay,
It's
yeah.
like
Just text it to me, dude. You're
it's
good.
all I don't. Fuck.
Yeah, I know. Yeah. Welcome to drugs.
It's okay. I'll tell you my experience with surgery also, so that
Yeah. What did you have? What
so
did you have,
that's fun.
Rampton? What surgery did you
So
have?
I've been put under, I think, twice.
Okay.
Um, so one I was doing on my wisdom teeth, and one I was doing like one on my lower back. It was like a skin condition. They had to like remove something.
Oh man. Okay.
And so the one on the wisdom teeth, like you know how everyone wakes up
Mm-hmm.
and
They're all silly and
starts
goofy.
talking gibberish.
Yeah.
And I remember my ex-girlfriend was like, I was so excited for you to get up and start
Yeah.
talking gibberish. All I remember is that I woke up from like almost like a dream,
Yeah.
and then I felt completely fine. I just started walking, and then the nurses was like, "What are you doing?" I was like, "I'm leaving," and they were like, "Go back to bed." Like,
I'm getting out of here. Peace.
yeah. And then they were like, "How are you walking so far?" I was like, "I don't know." And then they were like sitting me down. They were like, "This is gonna wear off." I was like, "I don't
Whoa.
feel anything
So I
yet
don't
for
feel
it to wear off."
shit. Y'all didn't do anything to
So,
me. I'm here.
so yeah, like I didn't feel anything except the pain started to
Yeah.
come out really
Oh
bad.
yeah, yeah.
And then I
That's
was like,
yeah.
I feel like this is the worst type of anesthesia that like I didn't feel any high or happy or anything. It's just like the pain was gone, and now that it's wearing off, it's just the
Yeah.
pain's coming
Dude,
back.
maybe you're like
But then that
Deadpool.
was
You can't feel pain or something, dude.
yeah,
Like drugs just don't work on you.
true. Yeah. And then the second time, it's like, okay, so you know how it felt so weird. I felt like I was having like a dream the whole time.
Mm-hmm.
And you know how like there are I don't know how to exactly explain this, but you know how like you have like one of these window tabs that you open up, and then there's like 1,000 of these like open up like on
Yeah.
your screen sometimes.
Yeah.
So it felt like I was like seeing something like that, and then these windows started like closing slowly, and then I just like was looking at the door.
Oh wow.
Like somehow it was a transition between like a dream. Like I don't know whether I was
Uh-huh.
awake and I couldn't figure out what's going on, but it felt like a bunch of like 3D like boxes that are like stacked on top of one another,
Yeah.
and they slowly started to merge into one shape that was like me looking right at the door.
So you
And
like
then
dissociated and then like reassociated reality or something kind of.
yeah, and I was like, what's going on? And then I remember being high,
Uh-huh.
but like I was fully conscious of what was going on, like what I was saying and everything. But like things were weird. Like I went to the doctor, and then I was like, "Yo, doctor, this was lit. What, what did you guys give
What'd you
me?"
guys give me?
And then the
Where do I
doctor
get
was like
this?
laughing, and he was like, "We gave you ketamine." I was like, "Isn't
Yes.
that a horse
Yeah.
tranquilizer?"
Yeah.
And then he was like, "Yeah." And then he was like, "But we don't give you like that much." And I was like, "And people do this drug on their own, like
Oh,
for fun."
recreationally. Yeah, 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 for sure. Yeah.
And then he was like, and then he was like laughing. He was like, "Yeah, I mean, some people do it. I wouldn't advise it." I was like, "You're gonna die."
Sound like you almost went into a K-hole. It sounds like a K-hole almost or something.
Yeah, but
All the
yeah,
sensory
it
stuff.
was.
That's crazy. Yeah, I have actually been noticing that they do this on my sister. She's a nurse and she sends me all these TikTok videos and stuff. But yeah, apparently they do give like ketamine to patients and
Yeah,
It'll trip you the fuck out. It's now
Yeah,
being used for like therapy, I think, for like PTSD and stuff. But you know,
Spinal decompression.
spinal decompression. Okay, that's what's happening to
yeah,
you.
but
Damn, you're
is it
young for having
the,
spinal problems.
are they
Yeah,
placing like
I don't know. I think it's like in my family or something. Like,
Oh,
I
okay.
don't fucking know.
All right, get some rest, Shaq.
these-
Bro, I'm let you know. I was trying to record a video,
Yes.
like a little uh, uh fuck, bro.
You got it, dude. You got it. It's all right. It's all right.
Uh,
Don't stress yourself.
life update, a
Life
life update
life
on
updates are
my
good.
channel, right?
Maybe
And
don't do it under
then
the influence of anesthesia though.
halfway in the game, I just fucking lost track of what I
Damn.
was doing. I just redeemed something. I haven't been in
Thank you,
this
dude.
chat in
Thank you, bro.
forever.
Yeah, you're making me hydrate. I think you should hydrate too, honestly though.
I drink like a lot of water.
Yeah,
already.
good. Hydrate and go to sleep. Like sleep it off, dog.
Yeah, I just had to do something, and then you were on the stream, so I checked on you.
I appreciate, dude. I was, you know, I miss you. Always come by, say hi and stuff. But
Yeah, I miss us too.
cool.
Pause.
Pause. All right, get some rest and stuff. I gotta help some kids with some math questions. Cool.
Yep.
All right. Good to see you. Good to see you, Pat. Good to see you, Shaq. All
Bye.
right. Let's kick
Bye,
off.
Ramit.
Bye, Shaq. Let's kick off the stream. Welcome everyone to Actual Education Office Hours. My name is Dr. Gold. Streamer will help you out with math homework, science homework, life problems. You know, we're here for it all. Anesthesia. Yeah, cool. That's a new one. Let me go through some of the chat real quick. All right. Nobody asked. There was also this one guy who put under but stayed awake and felt everything. He couldn't do everything. That's always like my worst fear, is that if they give me anesthesia that I'm actually awake, but you're still paralyzed and you can't do anything about it, so you're just feeling everything. You can't say anything. Yeah, that's a very rare thing. That doesn't happen very often to people. Noise says, new challenge. See how much alcohol Ramit can drink until he feels something. That one's good. Polish rectified spirits. Yeah, the Polish have some interesting drinks. They like they take like plums and stuff and they like ferment them. Interesting. Okay. And nobody else said they used to operate on babies without anesthesia because they thought they couldn't feel pain. Huh. That's an interesting one. Yeah, babies can definitely feel pain. Whether they can be vocal about it, I guess. I don't know. Okay, cool. All right. Lots of stuff. Awesome. Great. Interesting. All right, let's see. Who was the first question today? First question. Oh, is Noise. Okay, Noise. Oh, this is cool. Oh, I love this. Velocity versus time graphs. Actually, I just released a TikTok video on this one. This is actually a pretty good one, Noise. Says motion of a particle is represented on the velocity graph shown below. The motion is given by the equations. Great. Wow, what? This velocity is third order in time? That's not good. What does that mean, Noise? If there's a t cubed in the velocity, what does it mean that there's a thing that is non-zero? It's pretty cool. I was showing this earlier to people. Let me see what chat's he in. 1 sec. But yeah, okay. So what happens is we have. Oh, where was this? I have this picture of it. 1 sec. Let me find it. Wikipedia, and it was like jerk, snap, crackle, pop. This stuff. Where is it? Yeah, all the derivatives and stuff. Yeah, here we go. Love this. Where's this picture? Let's pull this in.
I've heard of jerk, not anything.
Right? I haven't heard of the snap, crackle, pop, dude, but it's real, apparently.
I feel like this is like definitely physicists just making random words just so that it
It's like the
makes
up
something
down
funny.
beauty and strange, you know, where all
Yeah.
the subatomic particles and stuff that they came up with. Yeah.
Yeah, I mean, I know, for example, there was some people that intentionally named their theorem in their last name in a certain order just so that it like spells out something vulgar.
Oh my god.
It's five mathematicians, and I was like, do you know how smart you gotta be to be able to pull this off, and nobody
Right.
can tell you
Yeah,
anything?
I know. Yeah, to have the chutzpah for it, dude. And they also do this with scientific articles. There are bounties for people to put certain words within scientific articles, like certain like ridiculous phrases. And if you can get it published in a peer-reviewed journal, like you win a prize. I think I've seen this before. Or what they try and do is they have the first letter of every sentence right within like a column, like spell something out. There's a whole like funny thing. One second. There's like it's like bounty on ridiculous words in peer-reviewed journal. Yeah, I mean we have fun, dude. We have some obscure words. I'll find it. There was something. I remember seeing it was like a challenge or whatnot. But yes, what we're getting at here at Noise is that if you keep taking derivatives of things, you get to what's called like the next moment or the next order of a quantity. In this case, position you derive, you get velocity. Velocity you derive, you get acceleration. And if my velocity is already of the order like t to the third, that means I can take at least 3 more derivatives before it's not non-zero or whatnot. So you can probably get down to snap or crackle here. Anyways, the reason I say this is because most times when people are going to do physics questions with position versus time graphs, velocity versus time graphs, everything usually stops here. Like acceleration is usually constant and not dependent on time. And as a result, velocity graphs shouldn't really have curvature to them. If they do, I don't know what's happening. This is some weird particle. This is some weird movement. Okay. Says a particle returns to its starting position at time t. Find the velocity of the particle at time t. Oh, so they want to know this. Oh, that's cool. All right. How do you know how to do this one, Noise? Do you have an idea how to do this one? It's actually kind of a cool one. Yeah, it has to come down to if you want to know what, let's say, like, so delta x, which is change in position, or I think this is technically displacement is what it is. That's always going to be equal to the integral from, we say, like, t equals t0 to t equals t final. Yeah, he says, I feel like I can work through it. I just couldn't be bothered. That's okay. That's okay. Because, someone else will get something out of this, and I always like a little practice on doing integrals again. So what's interesting here though is that this velocity is what we call a piecewise function. So for those of you that don't know, like piecewise means it gets broken up into pieces, and those pieces are defined by what the values of t are. So in this case, we have velocity versus time, and I have that this velocity graph, like this curve right here, is equal to this equation for t is between 0 and 4. And then once we get to t equals 4, it turns into a different type of equation, which in this case is just a nice line. Cool thing about piecewise functions in this case, this is also, you guys will see this word before. This is called is it discontinuous, or like the derivative is discontinuous here for sure? I guess
Yeah, they say non-differentiable.
Non-differentiable. That's the word I'm looking for. Right? Yeah, good. This is non-differentiable. That's what it is. And so, anytime you see any like really sharp points, which are usually come out of having a piecewise function, that's where you can say like it's not differentiable there. Or the derivative is not continuous. I always got confused when I was younger, like what continuity was. But in general, it's can you draw something without lifting the pen up? Okay, so
There's one actually. Once we get to this problem, there's like a cool graph I'll also
okay,
hopefully show.
yeah, cool. So this is pretty decent. This is pretty straightforward. I'm just gonna integrate this function from 0 to 4, and then I'm gonna integrate this function from 4 to a time t. Okay. Oh, so they want it as a function of t. That's cool. Okay. So, and I know that the summation of that displacement has to eventually be 0. So since all this area is underneath the x-axis, this means that this is going to be negative displacement, and then here we're going to end up getting positive displacement. And so they're going to cancel each other out. Oh, okay, very cool. So eventually I can say that just this is going to equal this. So I'm going to say, well, the negative of it, sorry. This, and what is this? This is 2t squared minus 3t minus 1/3 t cubed is going to have to equal this one, which is 4 to t of 1.5 lowercase t plus c. All right, cool. Integrals. I know you guys know how to integrate. If you don't, you can ask me. Okay, so this is going to be 2/3 t cubed minus 3/2 t squared minus 1/12 t to the 4th. Okay, then let's just distribute the minus. Sorry, that's a minus. That's a plus. That's a plus. Okay. That's from 0 to 4. And then this is equal to 1.5 t squared over 2. So what's that? That's 3/4. It's interesting they put a decimal here, but they put a fraction over here. Yeah. 3/4 t squared plus ct. And this is also from 4 to t. Okay. So then I plug this in for everything, and I subtract it from plugging this in for everything. Oh, this is ugly. Okay. I can see why Noise was like, I just don't want to do this. I feel like when you get to a point where you get so smart that you know how to do things, this just looks tedious, and it is. It is tedious, for sure. And then this is 3/4 big T squared plus C big T. Minus plugging that, so what? That's minus 12. 4 squared is 16. 16 over 4, yeah, 12. Minus 4C. It doesn't take any more sense anymore. Yes. Okay. And we want to find the velocity at t.
So in here, I'm pretty sure you can find c as well.
Right?
Yeah, because you have continuity. So at t equals to 4, you should have the same velocity.
I like that. I like that. I like that. Yeah, because there are two things that are unknown here, right? I don't have T and I don't have C, but yeah, that's a very Rampton brings up a very good point here. Yeah, and this goes back to the continuous thing we were talking about, because this function and this function, as we get close to t equals 4, equal the same velocity, right? Do you see how it doesn't jump or anything? They should be approaching the same value. Then at this boundary, when t equals 4, this function and this function should equal each other. So, yeah, very good. Yeah, I was wondering about that. I was like, wait, I have like two things I'm missing here. 4 to the 3rd is equal to 6 plus c. Okay, so that's 2 times 16. Oh, man. Oh, so much math. Does 64 even go? Does 3 even go into 64 in a nice way? My middle school it doesn't, right? Yeah.
64 is just 2 to the 6, so.
Oh.
It's just...
but we got this 1/3 here. It's just ugly. Oh man, dude, Noise. This is such an ugly question. Okay. C is equal to 32 minus 12, which is 20. 20 minus 6 is 14. So what's that? 14 minus 1/3 times 64. That's 52. 52 minus 64. Negative 12 over 3. Oh, okay. I think it's just negative 4. I think that's what that equals. Let me know if it's not. I'm pretty sure it is. Did I do that right? Let me think. Sorry. This is 32 minus 12, right? That's 20.
Yeah.
Then minus 6 is going to be 14, right?
Yeah.
So then I have 14, and then if I to the third, oh, that's 42. Oh, sorry. That's 42 over 3 minus 64 over 3. Oh, that's not something nice. Okay. So it's negative 22 thirds. Okay, that's what it is. Okay. I was off by 10.
Mm.
All right.
You can just plug it in for C, I guess, already there.
Yeah, right? Yeah, I can just plug this in. And then, but then I need to solve for t. Oh, man. Which this is going to be quadratic. Quadratic and t. Okay, good. Noise. Yeah, noise got the same value for c. That's good. Okay. Negative 2 thirds times 64 plus 48 over 2 plus 256 over 12 equals 3/4 t squared plus minus 22 thirds t minus 12 plus 88 over 3. Okay. Why? What? Where did this question come from? Like, why do they just give you this? This is torturous, dude. This is just like torturous algebra. Nobody asked, what the fuck is this? Okay, here. Let me explain real quick to nobody, because nobody's wondering. Nobody. All we're doing here is we're trying to solve for a variable here, which is t, is what we're trying to do. I know there are a lot of numbers and it looks really scary. But actually, it's a good question. Nobody, like, what grade are you in? Like, maybe you haven't even done quadratic equations, so maybe that's why this just looks like gibberish to you. There is a lot. Yeah, there's a little bit of math, but it's mainly just algebra. Is what it is. He's in 7th grade. Okay, I don't even think 7th graders have gone through the quadratic equation at this point. I don't think so, right? I mean, I was pretty advanced in 7th grade, and I just started going through it. Yeah, 7th grade. Okay, don't worry too much about this. Nobody. This is it's a little above what you'd be dealing with. You know what? I could solve this by hand. I'm not going to. So I'm going to show you how you can do it. I know how to do them, but we don't do them until 8th grade. Yeah, that's okay. Where's my calculator? Where'd you go, calculator? There you are. Oh, it's the wrong color. 1 sec. Let me fix that. 1 sec. Options. Skin. Yeah, use that. Come on. Okay, good. All right. Awesome. Okay, cool. All right. I'm just going to see if these two things, like, solve to anything. Negative 2 thirds times 64 plus 24 plus 256 over 12. And then let's add the 12 from the other side. And then let's minus the 88 divided by 3. Okay, cool. And then this was 0.75 t squared minus 22 over 3 t. Cool. Let's trace them. See if they come to be anything nice. Probably don't, actually. Okay. There's that. Okay. So we gotta zoom out. That's what we gotta do. There we go. Line. Where did she hit? Oh, hits in 2 places. Okay. Does that make sense? We could have 2 different t's for this. I don't like that. I don't like that they're both. Because if I do the intersect of, what is it? This one and this one. The TID4 sickens me, dude. No, it's the one calculator in the US that they allow you to use on all this, like, SATs and stuff. You kind of have to use it. Okay, I got t is equal to 2.8. Is that what you got, Noise? Did you get 2.8? There's technically another solution as well. But that doesn't make sense. I don't think there should be another solution. If I look at this, there should only really be one, right?
It
Ramped?
probably is gonna give like two solutions. One of them is gonna be is gonna be rejected. So like, how many solutions do you have
I have
for this
2,
one?
but I should only have 1, right? Because there should be a set amount of negative area here, and then there's only so much positive that I can add to it, right?
Yeah, I mean, like, what are the two solutions? I
Uh,
guess.
2.8. They're both positive is the problem. 2.8 and 2.8 doesn't make sense
Oh,
because
yeah, 2.8 is because
it's
it's less
below.
than
It's
4.
less than 4. Very good. Yeah, thanks, Rampton.
Yeah.
Yeah, you're right. Yeah. So this is not a good one. 2.8 is not a real solution, right? Okay. Yes, the other one is though. Yeah. Okay. That's what I was looking for. I was like, I need one of these to be nonsensical. Okay. There we go. Okay. That's 6.97. Okay. And then now if you want the velocity there, at this time, you just plug that in for here. So that's just 1.5 times the 6.7 plus the negative 22 over 3. Let's see what that becomes. That's 1.5 times 6.7, good, minus 22 thirds, 2.72. Okay. I'm assuming it's meters per second. That's what it should be. Yeah. Lots of stuff on that one. That's a and honestly, like, I could have spent another 20 minutes probably doing all this algebra by hand, but I didn't want to. At the end of the day, this is why it's very useful to be able to know how to use your calculator to solve things. This is why graphing calculators are so powerful, is that you can always set one side of an equation equal to, for instance, some function like y1. You can set the other side equal to y2, and then you just graph them and find out where they intersect. Integrals seem way too confusing. They're not too bad. Nobody. Don't worry. Integrals actually aren't that bad. There's some simple rules that I can go over later for doing integrals. They're not that bad. Yeah. They're actually one of the easier things, I think, to do in calculus. Series and whatnot, those get difficult. Although it is, yes, it's basically how you just find the area under a curve. Okay, cool. All right, good job, Noise. Integrals aren't the worst. Famous lad word. Well, they can be the worst, especially if you have to start using those tables of integrals. I don't, yeah. Or if we start doing like hyperbolic stuff and whatnot, yeah, that stuff can be bad. Who am I giving this to? I'll give this to Noise. Nice. Okay, cool. All right, let's see. Next. Oh, you wanted to say something, Ramton, right? Like a graph or something? What was up? What do you want to show?
Oh yeah. So because you mentioned something about differentiability,
Yes.
and so any I guess like zooming on this graph as well, just so that we have like a clear kind of example of what it is.
Here, let me
So
put a new. There you go. Just a new clear one
so
right
like,
there.
looking at this graph, at the point where we have like t equals to 4,
Mm-hmm.
we have like a jagged edge,
Yeah.
right? So idea of continuity for the people who are like trying who are what's it called, if they're any confused by the
Like, what does
terminology, I
continuous
want
mean?
to just explain. So continuous or continuity means that it kind of like all is like a smooth graph. Like you can draw this graph without ever lifting your pen off the page.
Right.
So you can see this is a continuous graph. Now, however, um, if we look at the derivative at t equals to 4, the derivative is not going to be is not going to exist. The reason is because slightly to the left of 4, or like the limit as we reach 4 from the left side,
Mm-hmm.
is negative, and then when we reach from the right side is positive, right? Exactly. So if you were to follow like a path, so this makes it so that they're different. Sorry, the derivative does not exist, since it is called non-differentiable.
Mm-hmm.
Now, there is a graph that makes it continuous but non-differentiable at every point. That means
Interesting.
there's jagged edges at every little bits of it,
Uh-huh.
and but it's continuous. Now, if you the reason
How would you
I
do
know
that?
that,
How would you do that? How would you have jagged edges but it's still continuous?
so Google Weierstrass's function. I think.
Oh, is this? Oh, we were talking about this earlier, weren't we? This was one of the questions.
Oh, was it? Oh,
Wasn't
okay.
it the the what? Was it? Wait, what's this? Wait, sorry. Strauss.
Weierstrass function.
Weiss.
Yeah. So he did the Strauss. It's just one word.
Oh, Wire Strauss. Oh.
Weierstrass. Yeah.
Oh, wow. This is cool.
So it's like this is a cool example of what we also call a fractal. So when you zoom in, you just keep getting more and more copies of this as well.
Oh, I see. Okay.
And so that makes it so that this graph is continuous, as you can see, but every time you zoom in,
Yes.
you end up getting,
Something that's just even more just jagged.
yeah.
Oh, I see. So you can't take the derivative anywhere because as you try to zoom in, it just becomes more and more just like rapidly changing points. Wow.
Yeah.
Oh, that's
Also,
I didn't know that.
We have someone in this or Twitch that is a algebraic geometer.
Yes. Yeah. Oh, so this is Hypatia. He showed up on Friday.
Oh, okay.
Yeah. I think just found the Twitch and whatnot, but
Okay.
I'll let them speak for themselves. But something I think they're a math professor. Hypatia,
okay.
you tell me, Hypatia. It was something. Actually, sorry. They very interesting story. I think they're a asylum seeker from China who came over to the U.S. and is now teaching math in New York. Is what it is.
Ooh, okay.
Yeah, there's a very interesting story to Hypatia. I remember I went over it earlier. Oh wow. Okay, this function is dope though, bro. What?
Yeah, it's a pretty cool.
Oh, that's
It's a pretty cool
cool.
function.
See, this is the type of stuff that like again I was never even introduced to this when I was in math class because it was kind of just here learn integrals, learn derivatives. But I feel like if we showed students like hey, there's actually some cooler stuff related to math, I would have been less scared of it. I would have been like, oh, okay, there's a point to this stuff. Yeah. Like, how did they come up with this stuff? What topological space? What? Oh, it's a Riemann function. Ah, okay. See? And then we learn Riemann sums and everything for integrals, but... Oh, I see. This is the cosine thing. Okay.
Yeah, so it's defined by the by like a Fourier
Sure.
function, I guess.
Sure, yeah.
It's
This looks like a Fourier decomposition.
Yeah.
Oh. Okay, very cool.
Hypatia. Well, nice to meet you, Hypatia.
Yeah, nice to meet you, Hypatia.
I
Yeah, one sec. Hypatia, come up to speak. Yeah, come up to the stage.
would like
Yeah,
to learn
say
some
hi. Yeah, say hi.
algebraic topology.
Yeah.
Hello, can you hear me?
Yeah, I can hear you, Hypatia. What's up? What's going on?
I just want to tell you, like, usually when I encounter this kind of integral, I will teach people about the Liouville's theorem and also the closed form Liouville's theorem. So
Louisville's
that's an
theorem?
interesting one.
Oh, the
Yeah,
Louisville.
it's telling you, for example, so basically it's saying what kind of antiderivative can be expressed by elementary functions.
Mm-hmm.
Yeah, well, that's the thing. Like for example, antiderivative is supposed to be thought abstractly as an operation. Like it has properties.
Sure.
Some of the like polynomials you can have elementary antiderivative.
Sure.
But there are also other like special functions solution or things can be expressed in terms of special functions by using the differential field extension.
See, these are all
Or-
words where I'm just like, what?
Yeah,
I
and
get what you're
also
talking about,
I-
like with integrals having nice, the integral of this is sine, or the integral of this is cosine, or this is e to the x. But
yeah, basically this theorem tells you when can it be expressed in
Okay.
such a nice way.
I see. Can't
What's
everything
the-
be expressed as like a? Yeah, go on.
Theorem?
So what theorem
What?
was that again? Say it again. Sorry,
What, what,
Rampton. I was
what
speaking.
was the name of the theorem you said? Is it the Sturm-Liouville theorem?
No, it's not a Liouville number. That's
Yes.
Liouville number is about the irrationality of
Okay.
that number. The Liouville theorem is in differential algebra.
Differential algebra. Okay.
What's Liouville theorem?
Yeah,
Yeah.
no, not how. Like Liouville has a lot of results.
Yeah,
You need
he
to
did a lot of stuff.
specifically say Liouville's theorem differential algebra.
All right, let me do it. Let me find it.
Here.
I'm gonna do it, dude.
I thought you were talking about the Sturm-Liouville theorem for like the differential equations.
That's all related. Differential algebra has immense application in determining or probing the properties of the solution of differential equations.
Oh, okay.
Yeah, this is the one. This
Okay.
is telling you, like,
But-
so elementary functions are some like arithmetic operations and composition of
Sure.
elementary functions, such as, oh well, just the exponential, because other things you can express it with that, but well, yeah.
Oh, this is
And
cool.
also-
Yeah, because e to the minus x squared is like usually not something that's easy to take an antiderivative of, right?
That's called the Gaussian integral, I think.
Oh wow, this is
Like,
super cool.
It has a very quite geometric proof that like how you evaluate it.
I see.
Yeah.
Oh,
There
very
is
cool.
actually like the proof for this is actually really cool because you can, you pretty much extend this to like a polar field, and then you're taking the like an integral in 3D almost.
Oh, I
When
see.
you're
I
trying
think
to
this is maybe
find
it.
the proof from negative infinity to infinity to find that it's pi. It's
Uh-huh.
like you're looking at it from like a 3D point of view, I guess.
Oh wow.
Yeah, that's called analytic continuation. One quite interesting property about that is that when you extend the extension is unique. There is no other way no other complex analytic function that you can extend it beside that one.
Oh, very cool.
Okay.
That's
Like
cool.
the e to the negative x squared.
I think so,
Yeah.
because like the result basically says if you have an accumulation point in the domain, then the values the function takes there determines the entire analytic continuation.
Okay. The accumulation points for yeah, can you give a because I know they also call it fixed points sometimes. Accumulation point is like the more general term.
Limit point? Is that what it is?
Accumulation
Limit
points is
point,
like
I think
a set. Yeah, that limit point. That's why, like, basically, you have a point, say, on the real number line, you have, let's say, n 1/n. Like, you have a sequence of points for all positive integer n. Then
Yeah.
this is like the point 0 is an accumulation point because
Yeah, okay.
it
Where all
accumulates to there. You cannot, like there is a topological version for that, but yeah.
Mhm.
It says 0 is a
I think
boundary
that-
point, but not a limit point. Okay.
Yeah,
Okay.
I think the question that what's it called? Teacup has posted.
Yeah.
I think that has something to do with limit points as well.
Yeah, here, let's pull it up. Let's pull up Teacup's question. I like that. Maybe you can help with this one too, Hypatia. Yeah. This is the type of stuff that
Which question?
I'm gonna post it. One sec. It's gonna be coming up in here in just a second. Let me get it. This is where. So we have a couple students here, Hypatia, that are bored in their math and science classes because they already understand all the stuff that's happening, and
Yeah, I know, and I'd like to teach them like everything they want to know.
Oh, perfect. Exactly. Yeah. And this is where I lean on people who have more math knowledge than I do because, okay, cool. So here we go. This is the question. It says, let G be an open and an R. For those who don't know this means it's a real number is what we say. And suppose that for every n contained in N, I don't know what this means. Hypatia, what does this mean? What is this big N?
N in a natural number.
That's natural numbers.
Might contain
Okay.
0 or not, but yeah, like
Okay.
the interval 0 contains a point that does not belong to Z.
Prove that
Prove
0
that
does not
0
belong
is
to
not
G.
in G.
Yeah.
Okay.
Yeah. What is this?
That's exactly what I was talking about. So you can draw it, like draw a real line.
Draw a real line. Okay, let's do it. Let me draw a real line. I'm gonna do it. All right. Y'all guide me. All right.
Yeah, and so an open in R by definition is it will be the arbitrary union of open intervals and then you can take a finitely many intersections.
Okay. Let's try it. Let me decode that myself. What that means.
Yeah, so I'll write a few stuff also. So
Okay, cool. Y'all be my translators.
I think yeah, yeah. So I think my patient also, because this is the extent of what's it called? This is the extent of like real analysis or topology that
Uh-huh.
like kind of goes over my head a little bit as well. But I'm gonna try my best to also
Sure.
explain the parts that I understand as much of it. Because he said a terminology that is not actually that trivial. He said finitely many, which is
Okay.
not the same thing as infinite.
Finitely
That's
many
a
is the opposite infinite. No, right?
there is an arbitrary
But
number
that's
that
also very complicated. Like finitely many means that you like well, so infinite is very complicated. It
No,
means
infinity is
anything
like not
that
even
is
a real
not
thing. You
finite.
know, like yeah, right.
Like there can be multiple cardinalities. Why I say infinite here, I mean countable. And
Okay.
then there can be uncountable ones, and there can be to determine what uncountable means in terms of cardinality is a very deep thing that was solved like 50 years ago.
Okay. What do
Like
we mean
that's
by
called the
what do we mean by
Turing
like
hypothesis.
cardinality? Is that what we're saying? Cardinality?
Yeah,
yeah,
so
it's just
cardinality, when you have a finite set, cardinality means just how many elements in that set.
Okay. Okay.
And so if you can like finite sets as in 1, 2, 3, that's a finite set of cardinality 3.
Okay.
But if you say all the natural numbers, that's an infinite set with cardinality LF0.
Okay. Okay. Ah, I see. Okay. Okay. Cardinality is
the
size. Got it. Got it.
value of natural numbers. I forgot how they showed, but LF0 it like looks like this. It's an Aramaic
Alpha with like a dot like that.
yeah, LF0. So it's like the first what's it called? Like the smallest cardinality for the infinite things.
Yeah,
Okay.
so back to what I was saying, open in a on the real number line are like they are built up from open intervals. There
Okay.
can be unions of them, so you can have like two disconnected pieces of open interval, or you can have two intersecting open intervals that merges into one open interval.
Okay.
But you can only have finitely many intersections, because if you have accountably many intersections, you can make it that like the intersection becomes a single point, which is not open anymore. It's closed. So closed means you have a like it's the complement of open.
I see. I see. Okay. Open's kind of like infinite, and closed would be like finite. It's kind of
Not quite. A closed interval
close. Close
is
enough. Yeah.
also closed. A
Close.
closed means it contains all the limit points. One definition of that is like at least in the standard topology on R.
Okay. Okay. So related to this question, then, we're saying.
Yeah, so just draw an example of open set in R on that number line.
Open set in R would just be something like this, right? It's just it would be all the numbers.
Right.
Exactly. Right. Cool. That's an open set. Okay.
Okay, so you can see here, this open set contains 0.
Right. Good. Okay. Yes.
So you should be able to see that the condition the problem gives is not satisfied by this open set.
Oh. Okay. Oh,
right?
okay, okay.
So for every n
Yes.
for every natural number n, the interval contains a point that does not belong to G.
Yes.
So the like why this doesn't satisfy it is because there exists and such that the interval open interval from 0 to 1 over n does not contains a point that belongs to G. Sorry, contains like the sorry no uh
You got it.
this is a there exists and for all points that belongs to G. So the negation will be
Oh, I see. So the
for
logic is like
all
proving
n.
like the contrapositive of it, kind of. Is that what you're
Yeah,
saying?
yeah.
Gotcha.
Except when you do a negation, you change the quantifier too. So here
Oh, okay.
it's telling you that this specific open interval
Mm-hmm.
contains like does not contain a point that belongs to G.
Right.
Yeah.
I got you.
So one thing is also, is it okay if I delete this one?
Yes, go for
Just
it. Go
so-
for it. Go for it. Go for it.
Yeah.
You're good.
So the reason I wanted to delete this is because it would be easier to do this question. Because here's the thing: the intervals is from 0 to 1 over n, and n is an element of the natural numbers,
Mm-hmm.
which means that the biggest this can be is from 0 to 1.
Right.
Right.
Okay.
So that's why I wanted to just draw this and do it like this.
Okay. Let's see this. Yeah.
There's 1, this is 0.
And we have all the fractions in between because n can go to whatever.
Yes. So it would be like 1/2. This is like the second interval. There's like the 1/3,
Mm-hmm.
1/4, and then all this stuff.
Sure.
And so, yeah, I think I don't know if you maybe Hypatia could also write on the board, but
Yeah. Let me get.
my thought was, if you define a set such that A0 is an element of 0 to 1, and or sorry, for every interval contains a point that does not. Yeah, A0 is an element of 0 to 1, and A0 does not belong to G. And then I'll define A1 to be an element of 0 to 1 too, and then A1 does not belong to G. And then I can keep going. So AN would be an element of 0 to 1 over n.
Which is still going to be slightly greater than 0, right?
Also,
Because
this is frowned upon, so I'm gonna call it K
okay. Okay.
because they can. And then this is 0 to 1 over K. So what you can say is that this sequence A0, A1, A2, dot 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 AK does not belong to G. And you can show that the limit point of this is 0. Maybe I'm wrong.
Yes,
I'm
you're right. Keep going, keep going. You're right.
yeah.
Don't question yourself.
Don't
Yeah,
question yourself.
because here's the thing. I took one class in like topology, and then I studied the rest of it myself. And that class was like the hardest one I took because I studied physics, like mathematical physics. So I mostly know about like geometry rather than algebra. So,
Mm-hmm.
but yeah. So the limit point is
Like,
this.
let me try to help you reformulate your thoughts.
Okay.
Okay.
Yeah.
So let's say our goal is trying to say that this set G,
Yeah.
it will
You got it.
it has a accumulation point, a limit point that is 0, but it cannot contain that. Wait, let me get it. I can
Maybe,
draw it and
yeah.
then.
Maybe if you could let him also write on the.
Yeah, I gave him
would be
all
nice.
the link and stuff. We'll see if
You
we
don't have
can.
a tablet.
Ah, we gotta get you a tablet. Gotta get you a tablet. Welcome to the online teaching game. You gotta have a tablet.
I'm working on that.
Yes,
I
yeah,
have
it's all good.
a laptop that is not functional. Yeah.
Oh no, we'll get you there.
So every point interval contains a point that does not belong to C.
What is the interval G, Ramton? What is the G? What is it?
G is not an interval.
Oh, it's not?
G can be like I said, open interval can be like multiple open sets can be multiple intervals, but here it doesn't matter because you are only thinking about the situation around 0.
Okay.
So when we say interval is has to be one, like something like this. This is an open interval, but an open set could be like a sum of open intervals like this, right?
Okay.
A union of
Union
open
of them.
intervals, but that isn't quite relevant here because you are only thinking about the like an open neighborhood around 0.
Oh, okay.
Okay.
Contains a point.
From what I remember, the definition of an interval is that it has to be continuous, kind of like that, right?
Integrals are intervals.
Interval, not integrals.
Intervals
are
points in the intervals
So,
are
like,
like
this is not an interval.
points that happen.
Yeah. Oh, I
it's
see.
It's not an interval, but it's an open set. It's not an open interval, but it's
So an interval has to be continuous from a starting to an endpoint. Is that what we're getting at?
Yeah.
Connected, not continuous.
Not okay, but it has to have like you can't have like these big jumps in it. I got you.
Not an open interval.
Can you move back to the question? I'm writing down.
Yes,
I'm writing it down.
Yeah, go for it. Go for it. You go.
But open set.
Point, let's say x n in 0 and 1 such that x n is not in C, so that means for all n there exists xn in implies xn C, and then so let us try to prove if 0 is in J and then 1 has this, then
Here's actually, hey, Hypatia, you're writing it out right on like a pen and paper.
yeah.
So here's the cool thing. Let me take a picture of like what you do, and then let me come back to it and like go through it, so I can just make sure I can get some of the other kids' questions through. Because if they're like, yo, can we do a normal question, please? And like, believe me,
Never.
I love this.
You can do it. Yeah, you can do
Yeah.
that, and then I will finish writing it.
Perfect.
I will
And then send me the photo and we'll go through it. Yeah, cool. Awesome.
Wait, no, my answers.
No,
my
no,
point.
we'll get you your points. Don't worry, I like it.
Oh.
You're good, dude. You're good. Here, let me go through real quick, because we got two more questions from other students.
Teacup is like, yeah, I'm here for the point.
I know he's like, I'm here for the points, dude. I'm here for the knowledge. Like, I appreciate learning
I'm
from
here
you
for
guys
the
as well.
ball.
Why is this not pasting? All right, cool.
I'm here for the money.
Yeah, nobody said. Just when I thought integrals were bad, now we have this, whatever this is. Don't worry, this is like graduate level like math is what this is. Yeah, don't worry. You're not gonna have to do this in high school. Okay.
You're gonna have to do this tomorrow in your math class.
Oh, this is another one of these challenge questions, dude. A two-digit number formed by any two adjacent digits of a 2017. What?
Go just try to ask for no
God damn it. Y'all asking these like super challenge questions. What? 2017 digits is divisible by 17 or 23 if the last digit is 1. Oh, man, dude. What? Excuse me? The fuck is this?
That's dope.
Any two adjacent digits of a 2017 digit is divisible by 17. Or actually, no, this is not. I think this is wait. Okay, this is
Okay.
okay. There's two ways doing this.
Okay,
There is,
all right.
I think, the more rigorous way of doing it, but sometimes I like to cheat a little bit.
All right, let's cheat. Let's cheat today.
But it's not like, you're not wasting hours like doing this question.
Yeah, I don't want to waste hours.
So there's a number that there's a bunch of like numbers. I don't know, whatever.
Sure.
Every two adjacent digits of this, if we take them, they're divisible by 17 or 23.
Okay.
So let's actually take all of the different ways that this could be. So 17, 34,
Mm-hmm. Oh, I see. Okay.
51, 68,
Mm-hmm.
another 75,
85.
85,
And then we're done,
and
right?
then we no longer can.
So then we have 23, 46, 69, and then what is it? 92?
92. Is
And then
that
we're
it?
that's it.
Yeah. One,
Okay.
Yeah. There we go. 92. So, so if these numbers are right next to each other,
Yes.
there has to be a way that we have.
Oh,
to be
and
able
don't they
to
also have to be
solve them.
this way? Is this also what has to happen?
Yeah, exactly.
Right? Yeah, okay.
So if there is 17, right, the left of this is gonna, the left and right of this need to be such numbers,
Mm-hmm.
such that that number would either be divisible by,
So it has to be like 51 in this case, right? Because I don't see anything
Yeah,
else here
yeah.
with a 1 in the ones place, right?
exactly. So 51. But the question is, can we have 70 something that is divisible by one?
Ah,
of
we
these?
can't. No, we can't.
We
I don't
can't.
see 7 anything. Okay, so this is bad.
Yeah, this is how we're cheating our way
Okay, I
through it.
like
It's
this.
not
I like this. Yeah.
Yeah, it's kind of like more clever. Maybe there is a more rigorous way of doing it, but like
Yeah, with like some number theory.
yeah. So 17 can't be there.
Yeah, nope.
All right, now let's go 34. If there's 34, we could have 23 on this side.
And we get a
And we
46.
could have 46 on the other side.
Yeah, that one
Okay,
works.
So this is, let's say, a candidate.
Mm-hmm. 51
Now
won't
if we
work.
have-
Oh, wait. 51 will. Because you could have 80. You could have 51. Sorry, you could have 85, right?
yeah, but then 17 wouldn't work. Because then it has to be.
Oh, it has to be
17
one
on
from
the-
here and one from here, though. You're right.
No. It
Oh,
could be
no.
either of them.
Oh,
But
okay.
If there is 51,
Yeah.
then the next number has to be 17 in order for it to work.
Oh, but
once
17
there's
is bad.
7, nothing can't go to the other side of it.
Got you. Okay. So
Yeah.
goodbye 51.
So that's why 51 wouldn't work.
Uh-huh.
Hopefully I'm doing this correctly.
No,
But
I think you're
then
right.
there is
68.
68. We could have 85. We could have 46.
Okay, so we're good.
Okay, that's nice. This works. If we have 85, we could have
I don't see anything with 8. Oh, wait. I see 58.
a 58.
Right?
Or 68. Yeah, 68.
Or it's 68, sorry. Yes.
We already had. And then it has to be 51.
But 51 is no good.
51 is not good. Think so.
Yeah.
So then 85 wouldn't work either.
Okay.
Which means that 48 wouldn't work. Wait, this is downhill.
Wait, why? What? 48? We didn't have 48, did we? Did we anywhere?
No. 40.
46, you mean?
46. No. Yeah, where did we have 46?
Right here. 23, 46, right?
Okay, yeah. So then 46 meets it. 92.
I don't think 92 works because I don't think I have anything else with 9.
Yeah, so 92 doesn't work unless it starts with a 9.
Ah, okay. Unless it starts with a 9.
It could start with a 9. Yeah, and it also ends with a 1.
Oh, wait.
So it's
92 be
ending
okay.
with-
Wait, because what about 69 and 23? Sorry, my bad. 92 is okay.
Oh, yeah. That's at 60 now. Yes.
Yeah.
Yeah, so then I think these thing work for we can start with a 9. Yeah, this is fine. This is fine because we could the other side could be 46
Mm-hmm.
and then 2 could be 23. Yeah. 3 the other side could be 34.
Mm-hmm.
4 could be 46. Yeah. and then uh,
Okay. Oh, here's the interesting thing. The last digit is a 1.
yeah. So I'm pretty sure this is gonna create a pattern actually, and then
But
it
wait,
needs
but
to
we don't
end-
have anything with a 1.
yeah, the 51 that we crossed out.
Oh, if
The
it's the
reason is
end.
because we can't start with a 17, but we can end with a 1. So if we're actually 51 at here, then 85 works as well,
Oh, yeah.
because
Yeah.
then it would be like this. 68 works as well,
Uh-huh.
so that's fine. Um,
This is
I think
actually
here's what
it's
will
a
happen.
loop. It's a
Once
loop. It's
you
a loop.
write,
It has to be.
yeah,
The last digit has to
exactly.
be 51, which means the next one has to be 85.
Yeah, and then I'm gonna work backwards with the loop. So
Yeah.
if this is 51, this is 85, and this is 68,
Mm-hmm.
then this is 46,
Mm-hmm.
34, 23,
Mm-hmm. 92.
92, 69, 46.
Yeah.
Does anything? Oh, no.
Yeah.
And then 46, something that ends with 4, 34,
Okay. And then 23.
23, yeah, 23, and then 92.
Okay,
Yeah,
so
there we go.
so
And then we
we're
get the
looping from here,
pattern.
right?
Yeah.
Or where is it? Where is this
So I
looping
think
from?
the loop starts from a 40 from
Yes.
here.
Good. Okay, yeah, from here on. Okay.
90,
And then how big
equals
how big is the loop? It's
69. So yeah, like 46, 23, 69.
uh-huh.
Or I guess this is the loop. Yeah, you're right.
So it's 5
Yeah.
big, right? So if we go to 2015, that's got to be 403 loops, right? And then we
We
oh,
go
but
to
it's too much. Sorry, because we need 3 digits here at least.
yeah. So we need 3 digits, and you said 2050.
So 402, because 402, right, gets me the
Yeah.
the 2010, right? Or yeah, no, because I
402 times 5. Is that what you're doing?
mm-hmm.
Yeah, and then we go to 2015. Yeah, that's great actually. So this is gonna the last 3 digits is the 217, 16, and 15th digit.
Mm-hmm.
So past here we're gonna have 2000
14. So we have 4 more
14.
digits. 4 more digits
Yeah,
out.
so we go 2010.
Uh-huh.
Our loop has ended. So now we need to go 4 more.
Yep.
So we go 6, 4, 3, 2.
Yeah, so the answer is
So
2.
that makes sense.
Cool. Is the answer 2? Nobody? Is it 2? Let's see if it
Please
is.
tell us.
Please tell us it's 2. It is. Yes.
Okay.
That's a cool one. GG. Yeah. Oh man, dude, that's so cool that it loops like that and whatnot. Oh man.
Yeah.
Okay, so I have typed the answer up in
What's
the
up?
office hour.
Cool.
Channel.
Let's pull it up. Let's pull it up. 1 sec. I'll get you. Where is it? Oh, nice. You put this in latex too. I like this. Okay. Oh, so that's the question, and then here's the solution to it. Okay. Do you want to go through explaining this so that it might make some sense to some people?
Yeah, so as I said, like I figured out like a more if they know about topology, like the person would just know like the basis, which like every good kinds of topology can be generated by a basis, and for the Euro or Euclidean topology over the real numbers is generated by, as I said, the basis of form open intervals. Like that's the first sentence. And so the basis, it has this property that for every point in every open set, like the open set that the set open set has to contain a basis element that is that like that contains the point. So this is the central argument. In this proof, there will of course be a lot of other proofs, but so here we are using like a proof by contradiction.
I see.
So we are assuming that 0 is an element of
Okay.
G. So now there is like a basis element, this open interval, let's say from A to B that contains 0, and that is contained in G. So one may then find a natural number n such that 1 over n prime is less than b, the right set,
Correct.
like the delimiter. And this is, well, I should write that this is possible because there is this the Archimedean property of the real numbers.
Okay.
But like sometimes one just like one mathematicians write that they
Like 1 over
assume
anything is
all-
always going to be like a fraction, basically, is what we're saying.
No, it means something like you give me like this real number, it must be bounded by two numbers of the form 1 over n and 1 over m, one
Okay.
on the left side, one on the right side.
Got you.
And then this and also the rational numbers are dense, so like basically every two real numbers between them there will be a rational like a rational number. This, like, for example, if it's 0 and b, right now I'm just picking this specific rational number 1 over n prime.
Got
So
you.
if you think about it, you have 0 and you have another real number b, and then there will be a
natural
1
number
over
and prime.
for some n contained inside, right?
Okay. I get that.
Okay. So now you like 0. So this open interval from 0 to n 1 over n prime is a subset of G.
Yes.
Which contradicts the hypothesis because the hypothesis tells
It's proving that 0 is not contained in G.
No, we are trying to contradict with the hypothesis.
Okay.
Like we already assumed the contrary to the goal. We
Okay.
have already assumed. That
Oh, okay.
0 is
I got you.
That's proof by contradiction. So we are trying to establish this contradiction to the hypothesis that for every n there is a point that does not belong to G. But I have already we have already established that there is this whole small open interval inside of G. So so for every n that is greater than n prime, there will be no such point that is not in G.
Got
So
you.
that contradicts the hypothesis to establish this proposition.
Okay. Cool. I like that, dude. Thank you, man, dude. That makes a lot more sense to me.
Can you ask the person asking this question if they have followed this argument?
I don't think they
You know
have
who asked-
because the person asking this question is in 8th grade. So, they're very young for math, but they want to learn new things. So I think this is a very cool way of like, introducing higher level math topics to students who are like bored with what's going on in their classes. And even for me, dude, I didn't understand a lot of this
They are in
beforehand.
8th grade, but they asked this question.
Yes.
That means the person is really good, like really advanced in
Yes.
their learning. Like
Yes, yeah. Teacup is very advanced and is very smart and is very curious, and I like to foster that and encourage that. And so that's why I tell them to ask harder questions that they have no clue about because they'll at least learn something rather than having to, repeat doing the Pythagorean theorem over and over again until they're like bored, Who cares about
So
that?
do you want to ask the person, the teacup person,
Yes.
to ask me any question or for clarification?
For sure. Yeah, no, I will. Yeah, I'll let Teacup know. I'll make an announcement actually in the Discord. I'll give you like a position and whatnot, so that if anyone has like any higher level math questions they want to ask, or if they want clarification on this, for instance, they can DM you. Is that cool?
Okay.
Cool. Awesome. I appreciate that. Okay, we're a little bit over time, but I'm cool with that. So we had 2 other students with questions, but this is a good opportunity. I want you guys to, because we have a Cooper and Sawyer here. If you can try using the AI that they've developed to ask your math question, I'll give you a bond coin if you go through it. Just try it out. I realized today we spent a little bit more time on more advanced math topics, but it's nice to have a balance of things. So yeah, for Habib and Lemons, can you try asking that question using the AI that we have, and then just show me a screenshot that you got the answer from it. It's on right now. They said they have the bot working right now. I think they'll have it working for another 20 minutes or something. But I'm curious to see if they've added like equation stuff and whatnot to it. So let me know how it works. Otherwise, I will do your question first on Wednesday when we start it off. Cool. Ooh, he says I can abuse this. Yes. Yes. Yeah. Noise will definitely find Hypatia very interesting to keep asking math questions about, and I'm here for it. Okay. Cool.
Yeah, noise. Keep me in the loop.
Yeah.
I want to learn more topology.
Yeah. Right. Let's learn some topological geometry math stuff. I'm here for it.
I think one of the things I also realized in the question that
Sure.
what is considered a topology, so we can talk about like the power sets and all that stuff at some point if we want to talk about topology, because to tell that the geometry, the Euclidean geometry is generated by the set of A and B.
Mm-hmm.
We need to understand what is the definition of topology.
I agree.
Yeah, the topology is not about the power sets, but well, topology is an actual structure you give to a set to some extent, and
Okay.
then you can talk about what is open.
Okay.
And also to go over that, I will it will be a full course. I'm willing to take on that, but if you want to schedule me a time, I can teach topology, I guess.
For sure, yeah. So we have a whole stream on Thursdays that we do is more like open ended, just talking about stuff, and I'd like to get to the point where we can offer like full courses. Again, attention span is a big thing here. Is I want to make sure that like if you're spending the time to talk about a subject and whatnot, that you have an audience that's willing and like respectful enough to be there to understand it. So maybe it's something we can start with like maybe some like mini lessons, some like bite-sized stuff to get people like interested in it and whatnot. And even I would love to just improve my math knowledge in knowing these little things. And then once that builds into a community that is ready for that and whatnot, then I think that would be very cool to like start offering like more extensive courses in it. If people just want to learn through things.
Yeah, well, you just give me a 1 or 2 day notice.
Of course.
When you want me to talk about it.
Yeah.
I will prepare for it.
I appreciate that. Okay, cool. Maybe we'll do that for this Thursday.
Where do you teach, by the way, if you don't mind asking?
What?
Where do you teach?
In Long Island, the Stony Brook University next semester, right? But they will probably just assign me to teach a recitation, like a problem section for calculus students.
Yeah, so he's kind of like bored. He's like, I know much more math, but they're gonna make me just teach calculus.
Yeah, I'm an algebraic geometer, so I of course want to teach algebra.
Yeah.
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 Well, if you ever want to teach algebra, I'll definitely want to learn more. So
yeah,
because that's the area of math that I don't feel that much comfortable. I'm very visual person, so like I